okay through this thing?
Is it on?
Yeah.
I don't hear it
Oh,
coming
it was
through.
on. Yeah, but it's got no power. It gave me a green light for a minute when it was on, and now it doesn't anymore.
Here, let me take that back to him. Where the stream is going, so I'll check on the battery issue.
I'm going to start. I think I can speak loud enough without the mic for the moment, and Pete's going to try and get that fixed. So we'll start our discussion right now. So what I'm showing you on the first image, of course, is the satellite movie across the continental United States and adjacent waters. And Greg was kind of throwing me a little shade saying, yeah, now you like these color maps. And I do. I actually do. I'll say that I do. This is a pretty nice looking map. It's sort of fake color, but it's not fake news. So there's some pretty interesting weather across the continental United States. Number one thing of interest, and it's kind of the straggling last bit of a thing of interest, is this frontal structure off the east coast of the United States. I'll use this screen to come and annotate. And so this is a widespread feature across all the way across the Atlantic coast of North America, and there's Greenland, and it heads up into the Greenland Sea and the Labrador Sea. There was a really exciting event in far northwest France overnight, where they had some all-time records were set for wind speeds. And I want to show you a little bit about that as part of the current weather, but that'll be the last thing I say. It's not unrelated to a development that preceded the subsequent development downstream over France that was in our weather and over North America on Wednesday and Thursday. So we're seeing the last bits of that here. And so you can see a little bit of a cloud head developing for the next wave that's going to put itself together over New England and then into maritime Canada. Other than that, much of the western 2/3 of the United States is pretty clear. We've had some beautiful fall days. Greg went to 32 last night at his house. He's up on a hill in Middleton. I think we may all see 32 at some point over the weekend. It looks like Sunday morning will be really chilly. I'm not even sure we won't see a snow flurry. And it's already snowed in the Upper Peninsula, and it snowed in northern Minnesota last night. First accumulating snow at Grand Marais of the season, and that's only October 1st into October 2nd. So very, very early for their first snow, and pretty exciting if you like that kind of thing, which I do, as many of you know. So the western 2/3 of the country, pretty clear. A little bit of high clouds coming in over some of the mountain states. And then we had our convective clouds with showers all day yesterday, because we had a lapse rate of about 8 degrees per kilometer. And so with dew points, you know, reasonably close to the temperatures, we were close to 100% RH. It wasn't that hard to get the relative humidity to 100%. And then without too much trouble, you get free convection in the updrafts, and for a while, some free subsidence until you dry it out, and then you've got to work against the environment. But it was really nice to see on the radar, nice even spacing between the cells, the convective updrafts. If you were outside, you would have been caught in a shower at a moment, and then suddenly the sun would be out in the next half hour, so it was pretty nice. And you can see that same type of thing occurring again today over a little bit further south, but these would be just fair weather cumulus clouds. They won't turn into anything precipitating, I don't believe. We'll see when we look at the radar. Okay, so pretty nice fall day across much of the country. Nothing of any particular import for us in this part of the world.
Excuse me, whoa, can
Yeah.
I go back to that previous one?
Yeah.
See that rope thing coming down there off of Corpus Christi? Or actually off of Brownsville?
Oh, right here. Yeah, that's interesting, isn't it?
I wonder if that's a bore.
Yeah, I don't know. It's been cold over the mid-continent. It could be, I guess, yeah.
Undulate
So
bore.
Greg's pointing out this really fine-scale rope cloud that comes right across the central and southern Gulf of Mexico, and wondering if it isn't tied to some gravity wave sort of pulse known as a bore. And so that could very well be the case. And those things can get trapped against the higher terrain to the west and then propagate in a manner that has some characteristics of gravity-type currents. Well, was this trying to, let's see if this works now. Can you hear me through this thing? Okay, that's going to allow me to not scream. I like that. Okay, so let's go to the radar across the continental United States. And not surprisingly, where we saw our cloud mass putting itself together in New England and New York State, a decent amount of widespread but light precipitation across many of the states of New England, a little bit down over the southern portion of Florida, Some of that's more heavily convective. And then a little sprinkle here or there over the Dakotas, and then the same in the immediate lee of Lake Michigan. So that's probably benefiting from some of the same types of thermodynamics/dynamics that we had over us yesterday. A little bit of meager synoptic forcing, certainly nothing to discourage the production of showers, but nothing to strongly encourage them, except the surface boundary is pretty warm and certainly moist over Lake Michigan at this time of year. So that's a little bit of lake effect in the context of synoptic scale forcing. And then it looks like light precipitation in the Valley of California. We'll look at the obs to see. I bet you it's not. I think it's just probably radars are turned up a little bit high. Fog, more likely than precipitation. So across the country, a pretty nice day, weather-wise. And here is the West Coast infrared satellite image over the last 6 or 7 hours. There's Hurricane Marie. I'm not going to say much about the hurricane. It's a pretty intense Pacific hurricane, but it's heading into Pacific no man's land, so I'm not sure what its future holds, but it's a pretty decent storm. And we've seen this a number of times this year. The storms are so nicely isolated, I guess, from other cloudiness in many instances this particular season that you can see there's no question there's a cyclonic rotation to the center of the storm. But when you're on the far periphery, where the only clouds that are available are high clouds, one can't mistake the anticyclonic flow at that outflow level. And that's characteristic of tropical cyclones. Not characteristic of extratropical cyclones. This is the second in a series of 2 really monster events that have affected the Gulf of Alaska, Kodiak Island region, and they look almost exactly the same. The one that came through Monday and Tuesday we talked about in 452 was a beautiful storm, and we noticed a secondary development getting itself organized about this location far upstream. That became this primary storm. So it's been a pretty active week in the Pacific Basin, and that's nice because this is the time of year where you can expect to get, in a good year, you can expect to get a good number of decent storms, and it looks like so far this year we're on that chart. I'm really glad about that.
I can mention that Maria's proud to be a Cat 4.
Oh, is that right?
Yeah, so it's pretty strong.
Yeah, Marie's a pretty intense storm. Here's the state of Hawaii, and so Marie is in, as I say, it's not going to affect much land in the immediate future, but it's going to be a Category 4 storm. I think the Pacific Ocean temperatures are not anything like the Atlantic Ocean temperatures when you get out in this region, right? They're a lot cooler.
No, they're just warm near the coast there.
Yeah.
And
So.
near the tropical coast, because as you get further north, there's upwelling. So it's not expected to last much past about 36 hours.
Oh, is that right? Okay. But it's a nice looking storm. And they're only on M in the Pacific Basin. Very often, isn't it true that in the Pacific you go through the alphabet before you do in the Atlantic in most years? Isn't that right?
Yeah, well, they don't go into alpha beta. They just start the letters over.
Oh yeah,
'Cause they're
okay.
used to doing that every year. That's probably what they'll switch to in the Atlantic now.
Yeah, unbelievable, isn't it? They're going to just make a change entirely in the way they do it. Okay, here's our surface map. Let's take a look first at our own region. This is the current map, and maybe I should have got one from several hours ago so we could have got something close to what the minimum temperatures were. But you can even see on this map, snowing at Superior, or right near Superior, 34 over 32. This is not a particularly dense observation network on this projection, and yet we see a little bit of snow already. So that's our first observation on a surface map of snow for this cold season, and it's only October 2nd. So I'm pretty excited about that. 47, beautiful morning actually. Started out cold, 32 at Greg's house, 38 at mine. And my wife went out to play tennis at 8 o'clock. And so I thought, wow, who's this robust character? And she had a great time in it because it was almost windless, 5-knot wind, perfectly sunny, and 47 degrees by 11 o'clock is not so bad. So you can, if you're out in the sun and you're physically active, that feels pretty good. Widespread light rain in the immediate lee of Lake Superior. I'm not sure why exactly it's cold enough to snow there, but it is. Maybe it's an intensity feature because the dew points are all pretty low across there. They're around 32, a little bit higher than 32 in many of those stations. And it's colder and drier to the north, even though it's cloudy, 36 over 25 in southern Manitoba, so it's pretty, southern Ontario, so it's pretty chilly and dry to our north.
Andrew Quigley reported, or said that Lac du Flambeau reported snow at Tozee this morning,
Oh,
too.
did they?
Yeah.
Okay, is
He's
another
watching
place?
online. Cats
Awesome.
11 says the OB reporting snow is Ironwood, Michigan.
Oh, Ironwood, Michigan, yeah, that's Izzo's hometown.
Yes, hello Andrew and
Coach
Kutzel,
Izzo's
welcome.
hometown. Looking over in New England, where the dew points are as high as our temperatures, it's a pretty nice day across much of southern New England. Here's the widespread precipitation we saw on the radar. Light rain almost everywhere, but right about temperature and dew point are the same in the mid to low 50s. Further south, as you go along the mid-Atlantic, it starts to warm up slightly, probably because there's a little bit more sunshine, but dew points are low everywhere along the coast. And even when you get down to Florida, you're not talking about a really miserable, hot, humid day. The northern half of the state has dew points in the 40s, but temperatures in the 70s. That's just a beautiful combination. Not till you get to Miami or Key West, you're starting to feel really tropical again. Maybe Fort Lauderdale too, but you've got dew points in the 70s, feeling more like Cuba. And looking over the continent itself, further to the west, as far south as New Orleans, 75 over 44. I think you could count on one hand the number of days, not in December through March, where the dew point's 44 degrees in New Orleans. So that's pretty nice. And light offshore winds, just a beautiful day across the western Gulf of Mexico, broadly speaking.
Guess we had upper 20s in Sparta and Toma area, according to Jeff online.
Oh, is that right?
35 in West Salem.
Yeah, I think there'll be more widespread. There'll probably be a widespread frost this weekend, it looks like. Oh yeah, Sacramento has a smoke awe, but I meant to mention from the satellite picture, I'll show you, I'll go back to that. And where is that? Oh, where did I do that? Yeah, get to the end here. You can see this plume of smoke coming off the coast of California and curling up cyclonically off the Baja. So that's evidence of continued fires. They're not quite as extensive as they were a couple of weeks ago, but they're still ongoing down in that region. Okay, so let's take a look at some of our upper level charts. I like to start at 500 millibars, just from habit. And so here's the 500 millibar chart from 7 a.m. this morning. Strong horizontal temperature contrast along a fairly strong jet. Even at 500, we'll see it's a little stronger, of course, at 300. Wind speeds widely from 80, sometimes 90 knots along the East Coast. Coincident with a strong horizontal temperature contrast, remember, was precipitating in this portion of that long south-southwesterly flow, and that's immediately downstream of some curvature in the flow over Pennsylvania and the northern Appalachians. And we've got a broad upper trough that's settling in over us, and actually maybe it already has settled in. We'll see when we get to higher elevation or lower elevation, it's cold. But we already know it's cold when you look at this 500 millibar temperatures. Minus 31 at 500 millibars, Churchill, Manitoba. That's really cold for this time of year. We had yesterday minus 27 at Green Bay. Surface temperature was 52 or so that's like 11 C. We had a 38-degree temperature contrast between about 1,000 millibars and 5 kilometers above the ground. So the lapse rate was really steep, and that was the result of that was our showery weather. So we have another day of pretty steep lapse rates. I wouldn't be surprised to see a little bit of cloudiness filling in the sky as the day wears on. The thing that will counteract that is we're in broad northwesterly flow, and in this location, Wisconsin, we're immediately upstream of the cyclonic curvature maximum. So this subgeostrophy in this region, ageostrophic winds broadly headed upstream. Here's a flat, fairly straight part of the flow, so there'll be a little bit of convergence aloft here that might discourage some of that convective cloudiness.
Looks
at
like
least
there's a little
discourage
wave
organizing
by
it.
Calgary there, though, right?
What'd you say?
Looks like there's a little wave over by Calgary.
Yeah, this here is a really impressive next feature in
Well,
line.
I mean, a short wave right there, a little short wave
Yeah, here's
dropping
the.
south that
Oh,
will
yeah,
hit
this
us
one
this
here.
afternoon, yeah.
Yeah, this one here. Yeah, that's right. This one has a nice thermal advection pattern with it. This one is a little bit more sharply curved. And that's just what by this time maybe is on the North Dakota border right now. So that might provide just a little bit of assistance in organizing some of what would be spawned by a fairly steep lapse rate, almost like yesterday. So I wouldn't be surprised if we fill in nicely. That's good seeing that, Greg. That's right on. And then off the West Coast, we've had a very stormy week, deep trough after deep trough. Actually, short waves moving through one deep trough, and the most recent one here is just off Kodiak Island, 5,200 meters or so. Kind of a dilapidated thermal contrast at 500 millibars because it's deeply occluded by this time. We talked a little bit about that yesterday in 452. So let's go a little higher first, and then we'll go back to lower elevation. So here's 300 millibars, same time,
And you can see a very strong jet, wind speed max about 140 knots, just to the northeast of the St. Lawrence River. And broadly speaking, 110 to 130 in the purple. And it's strongly anticyclonically curved, anticyclonic shear across this broad region of the East Coast, and some of the precipitation, of course, that we saw on the radar is in that region. That's commonly the case in such features. The wave at 300 millibars is a little more impressive than it was at 500 even, so that's the one that's immediately on the doorstep. And then the next kind of wave is a little bit further upstream, but this is the most obvious feature in the flow that's immediately upstream of us. And then it's a broadly wavy flow. This has been true for the last several weeks. We've had 2 weeks, I think, off of our face-to-face, but the week that we started, I think there was a very highly amplified flow, and it's remained that way across much of the continental or the western hemisphere. Not sure about the eastern hemisphere. I pay a little more attention to this one, and but it remains the case. And if this were January, we would be maybe a day away from the overnight low minus 25 or something like that. This is a brutally ugly pattern for the middle of January for us. And yet, even in early October, it delivers the same types of goods. This is anomalously cold right now where we are. And we'd be experiencing the same thing. Anomalous cold in January somehow has more of a sting. Let's see what the 850 millibar chart looks like. And that's right here, and this is the beginning of the day this morning too. The Intermountain West is a mess, of course, because many of these stations are actually at or above 850 millibars, so we do our best to make some sense of that. You don't really see any patterns emerge until you see this baroclinicity across the Dakotas, Nebraska, parts of Kansas, and that's fairly intense baroclinicity. It's very warm to the west and much cooler to the north and east. So it's plus 12 in Rapid City and minus 1 up near Sioux Falls. So a fairly substantial temperature contrast. Just barely beginning to see a sense of a little bit of a troughiness in the geopotential. I'm not sure how much to trust it at 850. Maybe we'll go to 700 to see. But this starts to look a little bit like a lee-side trough, at least in the sense that it produces a trough in the flow and then broad southwesterly flow on the warm side of a baroclinic zone draped across the central plains. It always lends hope to the situation when we're kind of colder than normal, and then if you get flow across the high terrain, there's subsidence in the lee and it creates a local warm bubble, and then the southwesterly flow that follows from the troughiness that also is a consequence of the subsidence in the lee kind of pushes that air a little bit towards the northeast. And in this case, it's going to take its time, as it very often does, but it does tend to make us a little warmer as time goes on from the depths of a cold shot. In the wintertime, I'm always intrigued by the fact that the mountains setting up the lee-side trough and the warm bubble associated with it can also force a little bit of localized warm advection, and that can give us snow flurries. And I often think to myself when I'm going to the bus on certain days when it fits the bill, here it is snowing as I walk to the bus, and that's because there's Rocky Mountains 1,000 miles to the west. If they weren't there, we wouldn't have this snow flurry, and that's kind of cool, I think.
Well, you wouldn't even have the cold air if the Rockies weren't there, because the Rockies actually funnel the cold air over the continent. I don't think we'd have anywhere near the Arctic operates without the Rockies.
Yeah, the extremity we wouldn't have, you're right, but it would still be cold mid-continent. It'd be hard not to be cold, but not maybe
It'd be
as
cold,
extreme.
but we wouldn't have the gradient. We wouldn't just have this bubble of cold air coming down over us.
No doubt about that. Yeah, so the extremity ahead of time is exacerbated by the presence of the Rockies, and then the warm-up afterwards is exacerbated by them too. So it's, and in the intervening, in that time interval is where you go from cold and clear to cloudy and light snow flurries. Yeah, that's right. Both of those things are dependent on the presence of the mountains. So 700 millibars, just to see if there's any semblance of a lee trough at this height, because this is about the mountain height, and one doesn't really see it. The flow is too parallel to the high terrain, because don't forget, the Rocky Mountain massif goes like this, you know, from Alberta all the way down to West Texas, and the flow is just about parallel to it. So it's struggling, the flow is struggling to have a little bit of flow across the terrain. That may change in about 10 days, but it's not true today. There's very little flow across, it's mostly along.
Well,
and so that doesn't assist in the production of the lee-side trough.
let me point out something else.
Yeah.
The Great Basin High is back again.
Yeah.
And that's important for the fires.
It sure is.
They're getting westerly winds or easterly winds down there in Southern California now, on the south side of that high, so they're gonna start downsloping,
Yep.
and the winds will pick up, and it's gonna be really strong fire conditions again with their setup.
That's right, and this is on schedule. It's supposed to be first or second week of October. The prior disastrous fires were ahead of schedule, but Greg's right. This is a climatological feature, the establishment of the Great Basin anticyclone, and not only does that induce sort of a geostrophic easterly flow in the low levels, but the pressure is higher in lower elevations, and that forces flow through the gap. That's ageostrophic, but strongly downslope. Dries things out. If there's anything left to dry out, I mean, in some cases you might have a situation in which there's just nothing left to burn. There's certainly no more drying needed. It's been warm and dry the whole time. But it's exactly right. It's setting up. This is the Santa Ana season right now. And it's just beginning to start looking like that on the map. Okay, and one other thing I wanted to point out, because I've got, well, two things about the local weather and something about the regional weather. We just finished September, and here's the climatological data from Madison. Yeah, right? Yeah, it's Madison. And for the month of September, it was kind of a Jekyll and Hyde month. We had a period of relative warmth. These are the daily departures, especially so on the last days, 25th, 26th or so of the month. And then we had early parts of the month that were chilly. Overall, this led to a 1.2 degree below normal September for Madison. And so if I had to guess, I would have guessed the right sign, but I don't think I would have guessed it so small. I guess I remembered some of the colder periods in the early part of the month more than I remember the slight warm-ups that came near the end. So minus 1.2 departure from normal. It's usually 61 degrees here on average in September, and it was just below 60. The interesting thing to me is, and I've mentioned this before, but I was wrong in my prior mentions of it. I reminded myself, the only day of the whole month where we got to 80 degrees was the 2nd of September, 81 degrees, and it stands out. It's like a sore thumb. 78 was the next close approach, and that would tie the all-time earliest last 80 degree temperature in Madison, which it was also September 2nd, 1977 where that happened. The rest of the fall in 77, we never saw 80 degrees again. There's not any particularly robust horizon for seeing 80 degrees. We're going to get warm again. We're going to have some nice days next week, actually, but they're not going to be anywhere near 80 degrees. So we're past the mean last day, which is the 29th of September, and then the all-time latest was the 23rd of October. So we're 3 weeks to the day from that day, and I don't see in the next 5 to 10 a chance of getting to 80 degrees. So we might tie the all-time record for earliest last 80 degree temperature for the season. So that's kind of excellent. I hope that we can do that. I want to show you something else. This is, as you know, I've probably said it more than once, I keep track of the minus 5 degree air at 850 millibars and its northern hemisphere extent. And so this is the time series from September all the way to the end of December. So this will be December 31st. I put too many lines in here, but the main average is the blue line, the 1948 to 2014 average. They're not different. I just spread them up into climatological 30-year averages. And then each day is a tip with the maximum aerial extent ever and minimum. And here's the current time series for this past September. So this looks really warm. We have small area compared to the long-term average of 850 millibar minus 5 air. And in fact, on one day, let's see, this is the 30th, 29th, 28th. I guess it was the 29th and the 30th. We tied the all-time minimums for those 2 calendar days. But nonetheless, this is only the 10th warmest September in the last 74 years from the NSEP pre-analysis data anyway. So it stands out. It's in the top, 14% or so, but it's not a record. And so we've had worse in terms of not developing cold air in the northern hemisphere early in the season than we have this year. But this is a pretty bad year for the development of cold air. Regionally, I don't know the answer. My guess is that regionally the Western Hemisphere has done pretty well because we've had locally a reasonably couple of cold snaps, and the North America has generally been chillier, I think, than average in September. But for the whole hemisphere, the average aerial extent is way below normal. And I think that's because of what's going on in the eastern hemisphere. Siberia's been warmer, northern China's been warmer. Greg?
I have to wonder if the smoke is suppressing our temperatures this last month. Because we've had a lot of smoke come over and it's blocked out a lot of sun.
Yeah.
So that may have knocked a couple degrees off right there. Otherwise, we would have been above normal.
Maybe that's right. I mean, we're only 1 degree below normal, and we had a period of at least 10 days where the smoke was a major factor. I didn't think about that. It's possible, yeah. And the closer you are to the source, almost certainly that's even worse. So that's a really good point. Yeah. This is the whole hemisphere, so I think the fires in California start to look a little bit more like a speck compared to what it is 1,000 or so kilometers downstream. But the whole hemisphere trended toward warmer, and we were cooler regionally. And one of the factors may have been the fires. Yeah, it's possible.
Hey, John, before you get to your next thing, I just wanted to share a few comments that have come in over the live stream chat. James Hughes in New York said it's light rain there.
Okay.
Maggie Bruckner said, well, not as spectacular on satellite as the smoke from California. This fire on the Colorado-Wyoming border is putting up a plume as well that's transporting over the Texas Panhandle. And Maggie also shares that for the oft-neglected southern hemisphere, the ozone hole is deep this year. NASA's ozone site is reporting a minimum of 97 Dobson units for yesterday.
Wow. So, and this is about the time the hole shows up, right? Early October, the transition.
I think so, yeah,
to
right after the sun comes up, yeah.
Yeah, yeah. Wow. That's pretty bad news. Okay, then I want to show you one other thing. I'll get rid of this. We'll have frequent updates on that as the season progresses. And then if I could, I want to show you, I gotta make sure I find these things. I can't see so well with my other, the wrong glasses on here. Yeah, here it is. Here's one of them. So this is a series of maps from the Deutsche Wetterdienst, I think. And the German Weather Service and the Met Office does some work on these too. And I'm going to just show you what happens with this cyclone. The British Met Office is thrilled with all these fronts. And in the United States, you get loud voices saying never draw any of them. I think there's somewhere in between that we ought to settle on. This is maybe a little too many. Anyway, here's Spain, here's France, and it's the northwest coast of France. Rennes and some of the other cities in that location are the ones that are going to be hit hardest by this developing little storm. So this is 6Z on the 1st of October. Just a little bit of a depression in an otherwise broad region of lower pressure, but not very low. This is the 1,000 millibar isobar right here, so it's not really the most intense environment, seemingly. A very intense anticyclone to the south, to the east of the Azores. But here's the region where we're going to see the development, and I think these are every 6 hours or so. Let's see if that's right. Nothing's happening. Okay, here we go. So what's the time on that? That's 12Z, so they're every 6 hours. 12Z on the 1st, and then you can start to see in northwest France is the development of this little cyclone in the Bay of Biscay. That's the thing that's going to turn into something rather impressive. 992, where's it come from? It's going to go right across the northwest part of France. So 992, 969, so that's 23 millibars in 6 hours. This thing is an explosively deepening storm. This is 0Z this morning. And right in this portion of the country of France, they had some really extreme winds associated with that rapid development. Okay, so I think that's the last part of that. Then I want to show you some of the pictures of the wind gusts. So that's a fairly rapid development. 23 millibars in 6 hours is something. Patrick, what's the maximum 6 hour rate on your storm?
12 millibars, I think.
I thought there was a period it was almost 18 or something, but I can't remember off the top of my head. But anyway, it's you'll see there's a lot of similarities. These are the look at this. This is Storm Alex, Tempestes Alex. I don't know how to say French. And then maximum winds relative to what? I don't know what that means. But records are in the yellow star. Rennes. This is where Jenny Sutcliffe lives. This is Reggie Sutcliffe's daughter. She lives there. 116 kilometers per hour, but on Belle Isle, right off the coast, 186 kilometers per hour. That translates to 114 mile per hour winds. And they kind of came on suddenly. I'm not sure how well forecasted this particular weather element was for this region, but these were some really incredible wind speeds that were experienced in northwest France with the rapid development of this cyclone. So I want to just say something about, and this is courtesy of Tim Hewson at ECMWF. He sent this around to people on the map list, and so it sparked a little conversation, but these first couple of diagrams were right from his first email. So I want to show you, what did I just do? Probably something wrong. I want to just show you, before we go to Viz 5D, which is a far superior tool than anything else that we usually get to use at these discussions. This is Alicia Bentley's maps. I take them because they have a little bit more extent to the east across Western and Central Europe. And this is of 18 hours prior. This is 12Z on the 1st of October. So this is the region, and sea level pressure is in black, and this is a little bit lower than 1,000 millibars. Thickness lines from 1,000 to 500 are the dashed red and blue, and then 250 millibar winds are in the shading. And we get over 100 meter per second right in this location at 250 millibars at 12Z on Thursday. And here's the development region. It's at the end, Patrick, this sounds familiar, it's at the end of a northwesterly flow in the jet exit region, and this is where things really start to go crazy. I want to say we'd have to spend more time to do a more thorough diagnosis of this, but this is the big storm that I mentioned at the beginning of the discussion that was at the mouth of the Labrador Sea yesterday, and then today was a little more dilapidated off the east coast of Greenland. This development and the cloud head associated with that development has a lot to do with the strengthening of the jet in the northwesterly flow that in turn spawns the cyclone over France. So all these things are connected, and in 452, 751, we talked for a while about downstream development. And there's a ridginess in between this disturbance and the next one downstream. So there's an enormous amount of ageostrophic geopotential flux going downstream through that ridge crest. And that's a major factor in communicating between systems the energy that's kind of being generated. And I would say that most of the energy here is, or I should say this, a large fraction of the energy that's communicated is locally generated by baroclinic conversion. So that's what makes this really interesting to me, is that the individual storms in the sequence are generating their own energy. It's the only way you can do it is baroclinic conversion, and then they're fluxing it downstream. And so the upstream storm has an impact on this downstream one over France. So let's see, we'll go ahead and look a little bit into the future from an old forecast perspective. You can see the jet digging in northwesterly flow and the cyclone getting really intense by 0Z on Friday. And here it is right over northwest France. And here's the opening of the English Channel. So this is bad news for shipping in the English Channel, but it's really bad for intensification and the strong winds that I mentioned. So I just want to show you a couple of aspects of this storm from Viz 5D. And this is from a GFS forecast. It was initialized at 18Z, I think, yesterday on the 1st. I'll get this a little bigger. Here's my control panel. And the first thing I'm showing you is, well, first let's get ourselves situated. I guess it's 18Z Wednesday. So this is the first time 06Z, what am I saying? 06, yeah, it's a 06 forecast. I can't remember. We'll see the dates when we go up there. They're going to be every 3 hours. And here is the sea level pressure. And I hope you can see the domain. Here's Europe and North Africa, the British Isles, Florida, Maine, Maritime Canada, Hudson Bay. So this is sea level pressure every 4 millibars. Wherever it's 1,000 millibars or lower, I put it in yellow. Wherever it's higher than that, it's in white. Okay, so you can see what we're looking at. So let's step forward. And it's out of this broad region of low pressure over the British Isles, the Irish Sea, and places like that, where we're going to start to see development, and it'll be particularly in this sort of portion of it. So there's our development over northern France. Look at how fast that happens. Even in this simulation, it's really fast. So I'll go back a couple of times. There's not too much to speak of there at Thursday, 18Z, and then if you click forward, 6 more hours, yeah, there's something really wild there. 0Z, 6 more hours, it's even more intense. So it's right around the turn of the day, Thursday into Friday, that this thing is revving up fast. And there's the northwest part of France, right underneath the gun. So let's take a look at a couple of upper level charts. Let's see. Oh boy, I can't see very well here. All right, well, first of all, let's take a look at the PV. And this is colored by pressure. And so, I mean, this is interesting all by itself. These regions of orange and red are very high pressures for the 2 PVU surface, and then the blue is very low pressure. So this is higher elevation, lower elevation. Let me show you what this looks like from a horizontal, from a different perspective. Get this slice here. So that's a trench in the tropopause, right? I mean, you can see all the way down into this thing. That's a trench, and that's been dug out dynamically by a set of processes that we don't have enough time to really talk about in detail here, but nonetheless, I want to point out to you that there's something very interesting going on to dig out this trench. And right there, we have that red spot almost, where the cursor is. That's the deepest penetration of the stratospheric PV into the upper troposphere. And I can prove that to you by just tilting this up. You can see there it is, that little tip coming down on the front edge of this storm. And there's the cyclone. Let me get rid of somehow the white isobars are in the way here. And you can see that cyclone is right underneath that deep tropopause trench. Okay, so I guess I want to show you the evolution of this. Just animate it forward. So it starts out near the beginning as a fairly local trench. Right there, there's going to be stuff that comes up from the south and east. This one right here is another part of the disturbance that's going to matter for this development. And then look at that, look at what happens. Here's the upstream cyclone, and you can see the curvature in the almost comma shape to the tropopause, and then right, doesn't respond quite the way I expect, sorry about that. Look at that trench in the tropopause. So this depression here is tied to the Bain storm over the Labrador Sea, and then it kicks up this low PV in the cloud head, and that helps to dig a really deep trench right in there where the main disturbance for the French cyclone comes in. And there it goes to town. I'll just show you one other thing from this. It's hard to, put this all together quickly. I'll show you get rid of the sea level pressure for the time being. And I'll show you the potential temperature at 500 millibars through this thing. This is incredible. This is every 3 degrees, I think I drew this. Here's Spain, France. This is every 3 degrees Celsius. And that's an incredibly strong temperature contrast. The warm side is 318, and the cold side is into the 290s. So it's extremely strong. We have to look at a cross-section through this thing. And we can do that with Vis 5D quite easily. So here's the potential temperature cross-section. Pretty much through the maximum intensity. This is what it looks like. Let me do this. So that's what the horizontal, or the vertical cross-section through this intense upper front looks like. Really, these are also through every 3 degrees. So a really intense horizontal gradient in theta that extends from, we'll see in a minute, from near the top of the troposphere all the way down. It gets a little weaker by the time it gets above the boundary layer, but it's deep. It goes down to about 800 or so millibars. So that's a pretty intense upper front. And I think I've got the PV on this cross-section too. Let's see. Yeah, that's the PV. I'll take the theta off. So that's what the potential vorticity looks like in this cross-section. So this is a wall from the tropical tropopause all the way down into the lower part of the middle latitude troposphere. And that's a really steep boundary. Right along this boundary, there has to be, go ahead, Greg, there has to be a strong jet. And I'll show you that in a minute.
You can see, and there's other plots you can look at, but that's actually a tropical plume. And you can see the definition of it in that dome of potential vorticity the low potential vorticity dome that's coming in, that's forcing that fold.
And I've got another picture that I already blew away, I forgot to keep it, of integrated water vapor transport that comes all the way from the Caribbean to
Yeah.
wrap into this exact spot, right in here.
I
You're
think that's
exactly
actually tied to that disturbance that's forming near Yucatan right now. It's-
What, the
it's-
water vapor?
Well, the tropical plume seems to be anchored in there, and there's basically a subtropical jet component that's coming all the way from a region where the outflow from that tropical cyclone or whatever that thing is coming up into the region. It's a tropical plume. I'm not going to say it's tropical cyclone outflow because it's not really a tropical cyclone yet. That's near to Yucatan, but it is definitely a tropical plume, and there you can see it coming into the cross section right there.
Yeah, you can. And I wish I had another way to show that, but I don't. But here's the relationship between the strong horizontal PV gradient that we see in purple and the wind speed maxima. They're always co-located. They have to be. There's a dynamical reason for that. And this is 30, 40, 50, 60, 70 meter per second winds that are tied to this extraordinary PV gradient. And it spans from 70 millibars all the way down to, or maybe 100 millibars all the way down to about 800 millibars in the 30 meter per second ice attack. So this is a really intense synoptic environment that develops, as Greg points out, it develops because of features that have been developing in fluxing water vapor and low PV from the tropics, thousands of kilometers upstream. So there's a lot of cooperation in the production of such a structure as this. And then if it comes across in the right spot at the right time, that structure can lead to intense development. I'm going to want to show you one more thing from this that will resonate with people who have been taking 452, 751 and working on through that. So let me show you the vorticity at 500 millibars. Okay, so there's the vorticity. You can almost not even distinguish it from theta. So I'll have to zoom in so that you can. And I think I gotta go back to normal to do the translation, right? Yeah. It's pretty good, huh, Pete?
Yes, I'm impressed, John.
This is on a Mac keyboard. That's what Pete and I are joking about. And I figured out how to do this, emulating a three-button mouse. So here's 500 millibar theta again, Iberia, France. And this is 500 millibar vorticity contours, everything greater than, I think, 12 times 10 to the minus 5. And that contour unit's a fourth. And so the thermal wind is going to be roughly parallel to these 500 millibar isotopes. You can use it as a reasonable proxy for the thermal wind. That's an extraordinary horizontal temperature contrast, so a really large thermal wind in the vicinity of this disturbance. A downward migration or forcing of the tropopause produces these upper level vortex structures. And so here's a major piece of upper level vorticity. Everywhere from this spot downstream, this is strong positive vorticity advection by the thermal wind, and that's occurring right in the Bay of Biscay. Here's a little secondary vorticity maxima that's right off the northwest coast of Belle Isles, right there. And you've got a local vorticity maxima with, again, strong thermal wind cutting right across it from high values to low. That's precisely where this cyclone's developing. So how the vortex structure gets produced, how the thermal field gets produced simultaneously, and then how they work together in terms of the Sutcliffe development theorem to drive this extraordinary cyclogenesis is a really nice example of how one has to think about many different things at once in synoptic meteorology to make sense of it. So it's a really nice case that we could examine further. If you're looking for a case for 452 or 751 for research, wow, here's a really beautiful example of something you could have some fun toying with, right? So we'll have many others to look at. Greg.
An interesting aspect of this is you can find that the energy of this is not coming primarily from baroclinicity. The energy is actually coming from the tropical plume, and what you can do, what I've done before, is you look at the potential energy that's associated with that domed up tropopause, and as the fold is occurring and bringing down that vorticity, you see that potential energy dropping. So it basically switches from the potential energy to the kinetic energy of the jet, which then, through the quasi-geostrophic mechanisms, folds over the tropopause and drives it down. So the energy, it takes energy to push that tropopause down because it doesn't want to just, it's stable, right?
Yeah.
So you have to push it down. That energy is coming from the potential energy of the tropics. And that's what can be shown. That's how, in a very similar way, tropical cyclones can create this potential energy anomaly that will cause the tropopause to fold on its poleward side.
Yeah.
This I don't think is a tropical cyclone necessarily, but it is a tropical plume, which does similar things.
You know I'm not going to agree 100% with what you just said, of course.
Mm-hmm.
Because here's the thing. You always say it's the tropics that does everything, and I always say it's the extratropics that do everything. And somewhere in between is where the truth is. And I have a feeling that, so we're both guilty. We're both guilty of stretching the truth on one end or another. I completely agree with you that the tropical forcing manifested as cloud head development and latent heat release and all sorts of other things that pump up the tropopause height is undeniably part of what fashions this extraordinary thermal contrast and the jet and the vorticity. It's all tied together. But the baroclinic conversion that is stealing the energy from that setup is occurring because of minus omega alpha. And you have to have vertical motions that are forced on the synoptic scale to take advantage of what you've accumulated by this potential energy transfer.
It's absolutely participating. I think
Yeah.
the baroclinic energy would be hard to say the partition, but the baroclinic energy by itself normally doesn't drive the tropopause that much down. And I think
That's hard to argue.
I think that anomaly, which is then able to tap the baroclinic energy, is being initiated by the tropical plume, by the energy that's coming out of the tropics. That potential energy, there's a lot of potential energy. We call it available potential energy, right, in the tropics. That lifts that tropopause up. So if you take the air with those potential temperatures there, look at how high that air has been pushed up. That's geopotential energy that was created by latent heat release that's lifted that air up. The latent heat release has gone into lifting that air up. And so it holds that energy. And when that energy gets to the extratropics, it's able to fold down the tropopause. And then that sets off all these other things that I think you're talking about.
Yeah. Well, I think that you should show it, because you say you can show it. If you show that in a paper that links your ideas to downstream development or something else like that, I think that would be a mammoth contribution. And I know you've got it all figured out.
And that was the thesis of Stephen that we had, Ogden,
Okay.
a couple of years ago. That's exactly what he did. And we made the calculation of how much potential energy there was versus how much the energy of the Rossby wave increased. And they exactly match.
Yeah, that's really good, compelling evidence for that idea.
Yeah.
Yeah, so I think you should keep pushing it.
Yep.
So that's all I'm going to say about Viz 5D, but I wanted to use this to illustrate not only the great way that you can look at these storms, but also how valuable it is to use these fundamental ideas that we talk about in classes to really make sense of weather systems. There's no question that they work. That's why they've got the time-honored status that they have. So I'm going to quickly take a look at the forecast, and I'm going to do it in a somewhat unorthodox way just because I don't know of a better way to do it in the current setting. So we're going to have 3 different levels, and we're only going to go to about 72 hours, and then unless there's questions about the future beyond that. Because I want to focus on just this weekend. The next week is another interesting subject, but we're getting close to the end of the time. So 500 millibars, 850, and the sea level pressure forecast. And you could almost get away with just 500 millibars and 850 in the way that I'm going to describe what I'm seeing. So these are Pete's new MetPy maps. They really are nice. They look really nice. He can't help the fact that the data is so highly resolved that you get all these little splotches in the vorticity. I'd love to have like a double smoother put on top of this for the vorticity field for the purposes of using these charts as a means of doing simple diagnostics. That's the reason I say that. But here's the 500 millibar map that's valid right about now. It's a 12-hour forecast. I couldn't get the 12Z run in before the discussion, so I'm using the 6Z run from about midnight, the end of the brewer season. And here's the 12-hour forecast valid right about now. And as Greg pointed out, we have wave number 1 over Manitoba. There's a little bit of a wave over the Dakotas. This is probably the one that you saw just a little bit upstream. So this is the one we have to keep our eye on for the immediate future. And then this one will coalesce as it swings down through Saturday night into Sunday. And that'll be the main story for our region. As you can see, there's going to be stories in a lot of other places too, but I won't spend much time on those. And then, at the same time, here's the 850 millibar map for 18Z on Friday. And this is just a broad, I'm using the isotherms as a proxy for the thermal wind, because it'll start to get a little messy on the thickness field, but you can always do that. Lower tropospheric isotherms are a decent proxy for the mid-troposphere thermal wind. And so there's just broad northwesterly vertical shear all the way down to Little Rock from, you know, the north slope almost. And little waves that are embedded within that, including the one that's in the Dakotas now, will be affected by the interaction of the vertical shear with the presence of the wave. And there's Hurricane Marie. And so one has to worry about where that's going to go. These are pretty chilly temperatures, again, over North America for this time of year. And then the sea level forecast at the same time highlights some of those features. The thickness lines are the yellow alternating solid and dashed lines, and sea level isobars are every 4 millibars in purple. And then accumulated precipitation in 3 hours is shaded in. A little bit of lake effect precipitation ongoing, and we saw that in the radar. So here's the broad northwesterly vertical shear as demonstrated in the thickness field itself. And then here's just a little bit of a local minimum in sea level pressure that stands out from the rest of the environment, and that's close to the position of the upper wave. So that's the one we're going to watch. It's going to struggle to really develop, of course, but it is going to do something interesting. And let's see, I'm going to go ahead. These are every 3 hours, Pete, so I'm going to go ahead 4 times to get to 12-hour forecast. This will be valid at midnight tonight. There's wave number 1, goes right south of us. And here's the upper vortex structure, not as strong in terms of the absolute vorticity, but now it's closer to us. It's sitting over southern Ontario and north of the Minnesota border. And we're likely to see that's about where the coldest air at 850 is in a minute. That's why I'm looking at 850. So that's the broad complexion. We're still upstream of the broad trough axis, but we're in the position to, we're in the position to start to see some action from this next disturbance. This is the same time at 850, so we had our upper vorticity maxima congealing, even though it's weak, in about this region, strong thermal shear still in that location. So it's PVA by the thermal wind over northern Minnesota by midnight tonight. But still, very strong temperature contrast on the western boundary of this deep upper trough. And if we could just get southwesterly winds cutting across this, we'd start to see the temperature warm up here by advection. And at sea level, you don't see too much of a change because we're in broad northwesterly flow without too many obvious disturbances in that northwesterly flow. Very hard to change the surface pressure in that case because you don't have substantial forcing for upward and downward motions, and certainly nothing localized to help produce cyclones or anticyclones. A little bit of a troughiness that extends out across the plains that really it's hard to say that that's related to any lee side. And you can see this little thermal ridge there. That's tied to wave number 1 that slid past us. So this little bit of a pressure perturbation here, and even light precipitation along the Missouri River on the Nebraska-Iowa border is tied to that first wave number 1. Wave number 2 has a little bit of a minimum in sea level pressure right over central South Dakota. Okay, so this is now 500 millibars at midday tomorrow, and there's sort of what's left of wave 1 and 2. They kind of put their act together over Missouri and Kansas. But here's still the same upper troughiness with weak vorticity, about 2 times the Coriolis parameter, sitting now a little bit closer to us. It's now oriented on an axis from northeast to southwest, but to our northwest. So we're in a position to have to worry about that a little bit more at this time, given the proximity. And here's 850 millibars. Chile, you know, we're below 0. 0 is this line right here. So we're below 0 at 850. We're probably going to see fair weather cumulus, probably helped organized a little bit tomorrow afternoon by the near proximity of that upper wave, weak though it is. And that is about a little bit of a local cold spot. And you can see here's the strong gradient that now extends all the way down to the Alabama, Mississippi, but is extremely intense in western Canada because this westerly flow over the high terrain is producing a low-level warm anomaly to the west. And at sea level, where is that? Remember, we had our little vortex structure down in this location. Here's a little bit more of a signature of a local minimum in sea level pressure, but it's not really a cyclone. And then here's our anticyclone kind of building or sliding southeastward, as it should, in the direction of the thermal wind. And nothing really breaking out here in substantial ways, but a little showery activity, even in the forecast model, that's not tied to flow in the lee of the lake. This is just responding to the presence of that upper wave. So one more time's enough, because then I don't want to keep you here longer than I should. Here is Saturday night at midnight, or actually I think it's 3 a.m. Now the upper wave is right over us. The axis of the trough is right over the central part of our own state, probably meaning more likely that we've got a better organized but light precipitation threat by about Sunday midnight or just thereafter, 1, 2, 3, 4. And so still chilly. So the stability is going to be low. We have reasonably cold temperatures aloft, even as low as 850. And we have a little bit of forcing in the vicinity for forcing the air to rise. It might look a lot, tomorrow, Saturday night into Sunday morning, might look a lot like what yesterday did around here. Let's see if the forecast bears that out. And I think you can see a little bit more a widespread showery activity. Again, not because of the lee of the lakes. All of this stuff to the east is lee of the lakes, perhaps, but not this. This is all just light synoptic ascent, not discouraged by anything else, and encouraged by the weak stratification to produce a few showers. So it looks to me like Saturday night into Sunday morning could be showery. Let's just go ahead here, a couple of more clicks. And you can see the showers can kind of get a little more widespread for a period of time as the sun comes up. I think it gets even worse. It's shifted off to the east, but there's a more widespread region of showers tied to the upper trough later in the day on Sunday. And then after that, we have a period of really nice weather coming towards us, as I think you'll see. Anticyclonic conditions, warm air advection. This is now Monday morning. The anticyclone has slid to our south and east. Very strong southwesterly flow and uniform warm advection. Thank God it's uniform. That means you can't force the vertical motions in uniform warm advection, as we talked about the other day in class. But you can nonetheless have warm advection and temperature increases. So we'll be into the low 60s on Monday, Tuesday, and Wednesday. Nowhere near 80, but with reasonably clear skies in a really nice late fall, or maybe mid-fall week coming up is what it looks like, with a little bit of a shower on Saturday night into Sunday. And that's how I see it. The weather looks somewhat boring across the continent and adjacent waters for the next several days, but you can always find something. So, are there any questions or comments? Sorry I went over a little bit. Okay, if not, we'll see each other again next Friday, we hope. And hopefully the weather will be a little more interesting for the forecast. There's always something you can talk about in the current weather, so that was fun. Thank you, Greg, for your excellent insights as always. Pete, thanks for the taping, and thank you all for coming. Let's have a little more interaction. At 7:51, people, maybe after about mid-October, I'm going to start having you sign up in pairs to give the discussion. So that's what you're looking at. So kind of start thinking about how you would organize it. And then we can always talk about what you want to talk about. If you get here early on that Friday, I'm happy to do that. Okay? All right, see you all next week. Have a good weekend.
Thanks, John.
Before you turn that off,
Yeah.
what do you visit ID?
Oh, I might have already blown it away. I did. Yeah.
Okay, well, I sent you an email.